everybody, Mr. Covey here. And the purpose of this video is just to review transformations, which we talked about at the beginning of the year in Unit 1. And we just want to talk about them here because they're going to have a lot to do with this graphing of trig functions that we're going to do this unit. Okay, so it's going to be a quick video. I just want to recap how transformations work. Okay? So remember, we started with an original function. We can do transformations that are on the inside or on the outside. Here we have a +3 on the inside. I'm going to move it left. Okay. Why don't you pause right now and see if you can fill out the rest of these, and then we'll go over them. Okay, so that's what you should have gotten for those there. If you are having issues with this, it's probably because you're forgetting something about how these work exactly. So I want to do a real quick recap here. The way that you tell that a transformation is a shift is because there is addition or subtraction. Okay, horizontal is on the inside, vertical is on the outside, and horizontal ones work backwards. So plus actually means left, minus actually means right. The outside ones work normal though. A plus on the outside moves it up, and a minus on the outside moves it down. Okay, so you take a look at like number 4. So +7 on the inside is inside. It's a plus, so it's a horizontal shift. And because it's a plus, it actually moves it left, even though you think it'd move it right. Dilations where it gets a little tricky. Remember, dilation is another word for a stretch or a shrink. And the way you tell something is a dilation is if there's multiplication, division, and horizontal is on the inside, and vertical is on the outside. And again, the horizontal works backwards. Okay, so what that really means is you do the reciprocal. Okay, so if you have a times 4, it's really a, here, maybe it's easier if we write it like this. So if you have a times b on the inside, then the factor of your dilation is actually 1 over b. Okay, the reciprocal of it. For instance, if you look at number 3, it's a times 4 on the inside. Because it's times, it's a dilation. Okay, but it's on the inside, so it works backwards. So you don't do a horizontal dilation by a factor of 4. You have to make it into a fraction. You have to form the reciprocal. And so it's a dilation by a factor of 1 over 4. Okay, on the outside, if you have multiplication on the outside, it's still a dilation, but it works normal. Okay, so if you have a times b on the outside, for instance, then the factor is b. Works normal. For instance, for number 6, you're multiplying by 2 on the outside. It's a vertical dilation by a factor of 2. How do you tell if you have a reflection? Well, that is a negative on the inside or outside. And it's really like multiplying by a negative. Okay, so you have a negative that you're really multiplying by. Okay, it's on the inside. Think about a horizontal flip on the inside. It's over the y-axis. If it's on the outside, it's a vertical flip. That's going to be over the x-axis. Okay. A big mistake that a lot of you guys had on your trig interviews was that when you had a -2, for instance, let's say this was a -2 out there, then it is both a vertical dilation by a factor of 2 and a reflection over the x-axis. Okay, so a negative on number, basically in that case, when you're multiplying by a negative number, it actually does 2 things. It's a dilation and a reflection. We'll see another example of that again. Hopefully this is all coming back to you guys. The other thing that there were some issues with on the trig interviews was the order that you do the transformations in. Okay, for vertical transformations, you do dilations first, and then you do shifts. Why? Or sorry, how do you remember that? It's just order of operations. PEM does. You do the dilation first because it's the multiplication, and then you do the shift because it's the addition. And please remember, incorporated in with the dilations are the reflections. Because remember, you're really multiplying by that negative, so it counts as the same order of operations, okay? So reflections are in there with dilations. It doesn't matter whether you do the reflection first, the dilation first. Those two things are both multiplication. You can do them in either order. For horizontal, it's backwards. Backwards, backwards, backwards. The way to remember this is that it is reverse. Oops. Gotta spell reverse right. Come on, Mr. Reverse PEMDAS. Why is it reverse? Well, it's related to the same reason that all of the horizontal transformations individually work backwards. Okay, so you might remember that A, the plus actually moves it left. The times by B is actually 1 over B. Okay, they work backwards. And since they individually work backwards, you also do them in a backwards order. You do them in a reverse order. You do reverse PEMDAS. So you do the shift first, and then you do the dilation. And remember, when you do the dilation, that's when you also do the reflections. You need to know this. What's on the screen right now, you must know. It will really help you with this trig graphing. If you have this down, graphing this trig stuff is not going to be too bad. Okay. Real quick, do 7 through 10 here. Tell me the transformations, and try and tell them to me in the right order. Okay? Go ahead and give those a try, and then we'll go over them. Okay. Here's what I got for those. I kind of want to go through these a little bit slower here. Okay? So for this first one, I had 2 horizontal transformations. Why? Because I had 2 things on the inside. I had +3 inside the parentheses and a ×2. The +3 was left 3. The ×2 is going to be a dilation, but it's horizontal, so it's not going to be by a factor of 2. It's going to be by a factor of 1/2. Then when I thought about the order, I don't do the multiplication and then the addition. Because it's horizontal, I do it backwards. So I do the addition and then the multiplication. And the addition is the shift, and the multiplication is the dilation. So I do the shift and then I do the dilation. Okay. If you can have that down, you're going to be totally good with this trig graphing stuff. For this one, I've just had 1 horizontal transformation, a -1 on the inside. I moved right 1. Because there's only 1 horizontal transformation, there's nothing with orders with that. I can do that whenever I want. The only time you have to worry about the order is when there's more than 1 horizontal or more than 1 vertical. Because the verticals mess with each other and the horizontals mess with each other. But verticals and horizontals don't interact. Okay? So the verticals, there was a vertical dilation by a factor of 5 and there was an up 3. I have to do the vertical dilation first. I have to do the multiplication and then the addition. Because for vertical, you have to do PEMDAS. When I do the right one does not matter. I can do the right one first, like I wrote it here. I can do it last. I can do it in between them. The right one is horizontal, so it doesn't interact with the vertical ones. Okay. Same with number 9. This is everything tossed into 1. The most important thing with number 9, well, there's a couple important things, but first, when you see a -2 on the outside, like I was saying before, it's a reflection over the x-axis and a vertical dilation by a factor of 2. There's no such thing as a vertical dilation by a factor of -2. That doesn't make any sense. It's a reflection and a vertical dilation by a factor of 2. I chose to do those first, so I chose to look at the vertical ones first. And then when I'm looking at the vertical ones, I have to do those before the up 6. And then for the horizontal, I have to do the right one before the horizontal dilation by a factor of 4. But I could have done the right one and then this, and then done the vertical ones in that order. Again, it doesn't matter what order you do vertical first or horizontal first. It just matters for the vertical themselves that they're in the right order, PEMDAS. And for the horizontal themselves that they're in reverse PEMDAS order. Okay. Last one here. I did left 7. Then I did a horizontal dilation by a factor of 2. Be careful, to 1/2 on the inside. So I flip it to get 2. And then I did the vertical dilation by a factor of 2 last. Okay. I hope this is coming back to you guys, and you guys are feeling good about this. The last thing here is how to do this when you actually are given a graph, and this is kind of like what we're going to be doing when we do this trig graphing stuff. So I want you to go ahead and pause and give these a Actually, let's do the first one together and then I'll change that. Let's try the second one. First, let's identify the transformations. So here I have a vertical dilation by a factor of 2. And I got a down 1. And lastly, I'm going to do the right 2. Okay. If I want to actually do these transformations to that graph there, it's probably easiest to make a table. Okay, so there's a table with these 4 points from up in that graph. Now I'm going to do these transformations. Okay. The vertical transformations change the y coordinates. Horizontal ones change the x coordinates. So if I want to do a vertical dilation by a factor of 2 and down 1, I'm going to take my y's, I'm going to multiply them by 2, and I'm going to subtract 1. 4 times 2 minus 1 is 7. Negative 1 times 2 minus 1 is negative 3. Okay, so those are my new y coordinates, and now I'm going to take my x coordinates, and what's going to affect my x coordinates is that horizontal transformation, that right 2. So I'm going to take all my x coordinates, and I'm going to move them right 2. I'm making 2 bigger. I'm going to add 2 to them. These new points, negative 1, 7, 3, negative 3, 5, 5, and 6, 5. Those are my new points. That's my new graph. Okay. Oops, I think I made a little mistake there. That should be a 4 or 5 right there. My bad. This is my new graph. Okay, so I'm going to take those new points. I'm going to connect them. That's my transformation. That's this guy stretched vertically, moved down 1, and moved right 2. Okay. Go ahead and give it a try for number 12 here. Then unpause, check your answers. First pause though. Thank you. Okay, so that negative on the inside reflected it over the y-axis, and that plus 4 on the outside moved it up 4. So I took my x-coordinates from my original table, I made them the opposite, and I took my y-coordinates and I added 4 to them, and I got this graph. Okay. We're going to do a little practice of transformations at the beginning of class next period, but I hope this jogged your memory a little bit.